Welcome to the Deep Dive. Today, we're locking onto a single monumental source, Jules Verne's 1870 classic, All Around the Moon. This is really the ultimate deep dive into what you could call the very first blueprint for interplanetary travel.
That's right. And, for anyone who's maybe only read From the Earth to the Moon, this book is the direct sequel, the thrilling conclusion. It's just a masterful fusion of, well, high-stakes psychological drama, meticulous physics, 19th century physics, mind you, and frankly, outright cosmic catastrophe.
Right, so our mission today isn't just a plot summary, we're going deeper. We want to extract the scientific theories Verne was working with, the conflicts between the characters, and those crucial, sometimes accidental variables that really determine the fate of the Baltimore Gun Club's, well, audacious trio.
Exactly. We'll follow the plot right from the moment of launch, analyzing, what Verne got right, what he got spectacularly wrong, and maybe why this journey still resonates as one of the greatest feats of, well, literary science.
Okay, so to set the stage, let's just quickly recap the premise from the first book. You've got the Baltimore Gun Club right after the American Civil War, and they've successfully built this enormous cannon, the Columbiad, down in Florida.
And their scientific aim was almost unbelievably precise. They had to launch this, 20,000-pound projectile from south of 28 degrees latitude, timing it perfectly to hit the moon when it was at perigee, its closest point to Earth. That's about 228,000 miles away.
And the firepower needed was just staggering. We're talking an initial velocity of 12,000 yards per second.
12,000 yards.
Just to give you some scale, that's over 6.8 miles every single second.
Wow.
I mean, most modern high-velocity artillery shells, they move at less than a mile per second. Verne wasn't messing around with the numbers.
No, he really wasn't afraid of big figures. But the real heart of this story, All Around the Moon, and where the conflict really ramps up, is the three men who volunteered for this, literal bullet ride.
Right. First up, you have President Barbicane. He's the visionary, the scientific leader. Verne describes him as having cast iron features. A man defined by this unshakable intellectual rigor.
But also prone to becoming incredibly rigid in his scientific assumptions. Right, that becomes important.
Yeah, definitely. And next to him is Captain McNichol. He's the secretary of the gun club. Barbicane's sort of mathematical counterpart.
The stickler for precision. I love how Ardan describes him later as a repeating chronometer. If a calculation is off by even a fraction of a second,
McNichol's on it.
McNichol will notice, and he will correct everyone involved.
And then, the wild card, Michel Ardan. He's this eccentric, shrewd, incredibly daring Frenchman. He's the one who actually proposed volunteering for the trip.
Just because he wanted to be the first human to investigate the moon, pure adventure spirit.
Exactly. And crucially, Ardan was also the mediator. He managed to reconcile this bitter, years-long feud between Barbicane and McNichol before they even got inside the cannon, which honestly might have been his biggest achievement.
Could be. Imagine being stuck in that tiny space with those two still feuding.
Right. Okay, so let's jump into it. Part one. The launch and immediate aftermath. They're locked inside, sitting on this massive powder charge. What's going through Barbicane's mind in those final moments?
Well, Barbicane, the meticulous planner, he's consumed by one worry: the terrible shock. He knows that initial acceleration, the sheer concussive force, could just pulp them instantly.
So he came up with a defense.
A really ingenious one for the time. Layers of water held in easily ruptured partitions right beneath the floor. The idea was they'd act like a hydraulic cushion.
So the partitions break on launch, the water gives way, and hopefully absorbs the worst of the G-forces.
That was the hope. But even in that terrifying countdown, you get that classic McNichol moment. Barbicane mentions 26 minutes left.
And McNichol just has to chime in.
26 minutes and 20 seconds. The precision, even then it's almost comical.
It really highlights the difference between them, doesn't it? Barbicane's focused on the big picture physics, McNichol's locked on the fractions of a second.
And meanwhile, Ardan's just being philosophical, using humor as his shield, basically. He dismisses the tension with that great line, 26 minutes well spent are infinitely more valuable than 26 lifetimes wasted.
That's pure Ardan, the French adventurer facing down American industrial might.
Perfectly put. And then, the moment arrives, the shock. Verne describes it less as an explosion they hear and more like a violent, concussive jolt. Ardan feels like he's waking up after a, quote, tremendous spree.
So what was the immediate damage? Inside the projectile.
Surprisingly little to the main structure. The aluminum shell held firm. Verne says, not a crack, nor a bend, nor a dent.
But inside?
Inside was chaos. Anything small and not tied down, tools, food containers, you name it, was furiously hurled against the ceiling. It's an early glimpse of just how dangerous inertia and momentum are in that kind of extreme launch.
And the humans. The physiological damage must have been intense. Ardan recovers first, right? What's his immediate instinct?
Survival. Pure survival instinct kicks in. The absolute first thing he does is check the internal atmosphere.
Why? What was the specific danger?
They were using this really volatile mixture of air and hydrogen for their lighting system. Ardan knew instantly that if the shock caused a leak, allowed that hydrogen to mix with the oxygen they were generating.
Boom!
Exactly. The slightest spark, maybe even from the friction of the launch itself, would cause an explosion that would, as Verne puts it, infallibly burst the projectile.
That is terrifying. So while Ardan is basically checking if they're sitting inside a bomb, Barbicane and McNichol are just out cold.
Pretty much. Described as inert masses. When Barbicane finally comes to, his first conscious question is the most fundamental one imaginable. Ardan, McNichol, are we moving?
And that leads to this really bizarre discovery.
Yeah, the sensory failure. It hits them hard. They realize they have absolutely no sensation of motion. None. In the silence, the frictionless vacuum of space, there's just no frame of reference.
Verne compares it to people on Earth not feeling the planet hurtling around the sun at hundreds of miles per minute.
Exactly. They're moving at this insane velocity, thousands of yards per second, but they feel completely, utterly still.
I find that detail just profoundly unsettling. Yeah. Moving faster than anything in human history, yet feeling nothing. And this confusion, this sensory disconnect, leads directly to that funny language error.
It does. It's a wonderful touch. Barbicane and McNichol are so physically battered and mentally scrambled by the G-forces and the shock that when Ardan starts speaking French, perfectly normal for him.
They think he's speaking English.
Both Americans are completely convinced he's speaking flawless English the entire time, and they blame their own disordered brains for not being able to understand him. It's this fantastic moment grounding the incredible science in just sheer temporary human confusion and, well, brain-addling.
It's a great reminder, isn't it? Even these brilliant scientific minds are still just, flesh and blood susceptible to getting knocked silly by extreme forces.
Absolutely. So, okay, the initial confusion starts to clear. Barbicane, being Barbicane, turns to his instruments. How does he prove they're moving?
He relies on science, not senses. He checks the thermometer inside the cabin, and it's reading a stifling 113 degrees Fahrenheit.
Whoa, that's hot. Where's that heat coming from? They're in space, right?
Exactly. It's residual heat generated entirely by atmospheric friction during their ascent. That single temperature reading confirms two things. They definitely achieved escape velocity, and they are now far beyond the regions of the atmosphere.
So the friction did its job heating them up, but it also means they lost speed.
Precisely. That heat confirms a crucial and maybe worrying calculation about their velocity. Their planned initial speed of 12,000 yards per second was significantly reduced, maybe by as much as a third, just by punching through the air.
Leaving them at maybe 8,000 yards per second as they enter the vacuum, that's a big loss of momentum right at the start.
It really is, and it immediately raises the question, do they have enough speed left to actually make it?
A question that will come back to haunt them. But before they can really dwell on that, they encounter another weird sensory thing. The missing sound.
Ah, yes. Barbicane and McNichol finally admit, sheepishly, that neither of them actually heard the cannon fire.
Which seems impossible, right? The biggest cannon ever built.
But Ardan, again the intuitive one, has the eureka moment.
He realizes they were shot upwards so fast, something like 30 times faster than sound travels, that the sound wave itself simply never caught up to them.
They literally outran the bang.
They outran the sound of their own launch. It just underscores how utterly their speed defies normal human experience.
Okay, so they're settling in, they've confirmed motion, they understand the lack of sound. Barbicane clears one of the side lights, the windows. What's the first view of space like?
It confirms they are definitely driving through space and not, say, sinking in the Gulf of Mexico, as Ardan jokingly suggests. The view itself is stark.
How so?
Extreme contrast. The stars are noted as being incredibly bright, but somehow looking smaller, more point-like, and crucially, the blackness of the sky is intense.
Because there's no atmosphere to scatter light.
Exactly, and that intense blackness makes the moon itself appear dazzlingly radiant. Even stars that are visually right next to the moon blaze brightly, which is something you just don't see from Earth because of atmospheric glare. They're getting a first-hand look at the clarity of the vacuum.
Amazing. But about 8 hours into the trip, The harsh realities of their confined existence hit them again. This time it involves their animal companions, the two dogs, Diana and Satellite.
Yeah, this is a sad moment. They discover the male dog, Satellite, didn't survive the launch.
What happened?
He was apparently crushed against the roof during that initial violent shock. The internal forces weren't just throwing objects around, they caused fatal trauma to a living creature. The female dog, Diana, she's okay, remarkably.
But Satellite's death immediately poses a practical problem, doesn't it?
It does. Barbican, always practical, frames it as a sanitation issue. They have to eject the body to prevent decay in the sealed environment, but he stresses they must do it with extreme care.
Why the extreme care? Just opening a hatch seems simple enough.
Air loss.
Yeah.
It's all about minimizing the loss of their precious internal atmosphere. Barbican explains their system. They can generate oxygen chemically using potassium chlorate. That's manageable.
Why?
But they cannot manufacture nitrogen. Nitrogen is the bulk of their breathable air, essential for regulating pressure and respiration. Losing too much nitrogen means the air density drops, the pressure drops, and they risk suffocation. Every molecule counts.
Wow. So ejecting the dog becomes this incredibly delicate procedure. They use the floor light, the hatch in the bottom.
Yes, they carefully open it, eject Satellite's body into the void. And this is where Verne gives us another fascinating bit of orbital mechanics.
The body doesn't just fall away or drift off.
No. Because the dog shared the projectile's exact trajectory and velocity at the moment it was ejected, it maintains that momentum perfectly. Satellite's body becomes, as Verne describes it, a permanent, motionless waif, forever accompanying them on their journey.
A silent, grim companion.
A dark tribute to the unforeseen costs of this venture, and a perfect, chilling demonstration of Newtonian physics in action.
Speaking of orbital mechanics and things flying alongside them, the journey gets terrifyingly interrupted, doesn't it? By something completely external.
Oh yes, the near miss with the bolide. A massive, brightly lit celestial body, basically a huge meteoroid, comes screaming towards them.
How does Verne describe their reaction?
Pure, paralyzing terror. He compares their sudden realization of the danger to being trapped on a narrow railroad bridge with an express train bearing down on them. Utterly helpless, nowhere to run.
And Barbican, the scientist, he identifies it.
Quickly, yes. He recognizes it as a bolide, but not just any space rock. This one was enormous, so large that Earth's gravity had actually captured it temporarily. It was acting like a dangerous rogue satellite of Earth.
Wow, so they dodged a bullet. Literally a giant space bullet.
Just barely. Their velocity carried them just slightly above the point of collision. But the crucial thing here, the detail we absolutely have to remember for later, it's the interaction. The sheer mass of this bolide, combined with how incredibly close they passed, exerted a brief but significant gravitational pull on their projectile.
A little nudge.
A little nudge from a giant rock. This single, random encounter in the void, it seems insignificant at the time, but it turns out to be the critical factor that knocks them off their perfectly calculated trajectory. It changes everything.
Okay, file that away. So once their hearts stop pounding, they actually look back down towards Earth through the lower window. What do they see?
An absolutely stunning view, apparently only possible because the moon wasn't full at that moment. They describe Earth as being encircled by this breathtaking diamond ring.
A diamond ring. What causes that?
It's a beautiful piece of physics, actually. Barbican explains it's an optical illusion caused by the refraction of sunlight through Earth's atmosphere.
The atmosphere acting like a lens.
Exactly, like a gigantic natural double convex lens. It bends the light from stars that are near or even slightly behind the Earth from their perspective, converging it, making the Earth appear to wear this brilliant crown of light. It's Verne using real science to create this incredible, poetic, celestial image.
That's fantastic. And while they're watching Earth, they also witness something else.
Yes, massive meteor showers. They see hundreds of shooting stars, bolides igniting as they hit the upper atmosphere, leaving these luminous trails. Verne even explicitly links it to the known phenomenon of the November-December perihelion meteor showers.
So Barbican's giving the cold scientific explanation that Earth is just plowing through streams of cosmic dust.
Right. Well, Ardennes naturally provides the more romantic interpretation. He prefers to think that Mother Earth shot off her best rocket signals to show that she still thought of them.
That's that constant tension again, isn't it? The rational versus the romantic view of the cosmos.
It defines the whole dynamic between them. And speaking of things getting a bit fiery, their survival is threatened again, not by something outside, but by a mistake inside. Human error.
What happens?
About 40 hours into the trip, they experience this sudden, really alarming phenomenon: oxygen intoxication.
Getting high on their own supply.
Pretty much. This is one of the weirdest, most memorable scenes. It turns out Arden, in his earlier excitement, hadn't fully closed the tap on their oxygen generation system.
Oh, no.
Yeah, he only half turned it off. So they accidentally saturated the cabin with highly concentrated oxygen. Hyperoxygenation.
What were the symptoms? It sounds dangerous.
It was, and bizarre. The light from just striking a match became blindingly dazzling. They felt this gnawing sensation in their stomachs. Their brains felt like they were throbbing, and they exhibited completely chaotic behavior.
Like what?
It caused this kind of frenzied, manic intoxication. Verne even describes the chickens they brought along.
The chickens, I remember this.
Yes, even the animals went nuts. The chickens escape their coop and start flying backwards and forwards blindly inside the projectile. And the men, they were capering like crazy students.
So it wasn't just feeling good, it was actually dangerous.
Very. The captain, McNichol, realizes what's happening. The highly concentrated gas isn't suffocating them. It's almost killing them by, as he puts it, literally burning them up through metabolic overload. Their bodies are running too hot, too fast.
That's incredible foresight from Verne in 1870. Understanding the dangers of too much oxygen. What did they do?
Barbicane and McNichol basically had to force themselves to sleep it off, let their systems recover. Arden, characteristically, seems less phased, and even uses the experience to speculate about using oxygen chambers for people who need a burst of intense activity.
They were the theorist. It's another reminder, though, isn't it? The internal environment is just as hostile as the external one, and human error is always a factor.
Absolutely. Okay, so moving on. As they travel further from Earth, further from its dominant gravitational pull, they really start to experience the main event: progressive weightlessness.
Right. The loss of gravity.
It becomes a constant theme. Barbicane had calculated this, of course. He knew the gravitational forces of the Earth and Moon would eventually balance out.
The neutral point.
The neutral point. And because Earth is so much more massive than the Moon, this point occurs much closer to the Moon, about 9/10 of the way there. So roughly 216,000 miles from Earth.
So they experience this gradual lessening of weight over a long period, peaking right at that neutral point. And this is where Verne has some fun describing it.
He really does. It's illustrated perfectly when McNichol accidentally knocks over a glass of water.
Yeah.
And nothing happens. Both the glass and the water just remain suspended perfectly still right there in midair. Zero gravity in action.
And Arden naturally has to play with it.
Of course. He immediately starts experimenting, arranging objects, bottles, their own arms outstretched, even Diana the dog, into this bizarre, symmetrical, floating pyramid, just reveling in the complete absence of weight.
They feel completely weightless, like drunk men trying to stay upright when there's no up or down.
Exactly. But Barbicane, even while floating, looks ahead. He calculates what gravity will feel like on the Moon.
Because the Moon does have gravity, just much less.
Much less. About 189th of Earth's mass, he figures, which means his own weight, about 150 pounds on Earth, would feel like only 30 pounds on the Moon.
And Arden, being lighter, would weigh hardly 25 pounds. They start imagining leaping hundreds of feet.
It's a moment of pure scientific wonder. But that serenity, that joy of weightlessness, is about to be violently shattered.
Oh, the big one.
The central dramatic conflict of the entire journey. It starts, as things often do with McNichol, with a calculation.
He's crunching the numbers again, using something Verne calls the integral equation of living forces. What's that, basically?
Well, for us non-19th century physicists, it essentially means McNichol is calculating the total energy and momentum they needed to overcome Earth's gravity throughout the entire trip to reach that neutral point with enough velocity left over.
Okay. And he plugs in the official number for their launch speed.
Yes, the figure supplied by the Cambridge Observatory. 12,000 yards per second initial velocity.
And the result?
The result is devastating. The equation shows that the required velocity just to reach the neutral point and have any chance of continuing towards the Moon was actually 17,958 yards per second.
Whoa. That's significantly more.
Over 50% more than the speed they thought they launched at. The realization hits them like a physical blow. They cry out, "Such a velocity will never do." The immediate paralyzing fear: "We shall fall back to the Earth."
And Barbicane checks the math.
Barbicane checks it. He can find no flaw. The math is sound. The fear is completely justified by their own science. They calculated their own doom.
Yeah. So, how does Verne get them out of this? How do they escape this mathematical certainty of failure?
Barbicane, ever the practical thinker even in crisis, realizes there must be factors they didn't account for. Two crucial, uncalculated variables.
Okay, were they?
First, he speculates their initial velocity must simply have been greater than we had expected. Maybe the gunners put a bit too much gun cotton in the cannon. A slight overcharge.
Plausible? Maybe lucky? What's the second factor?
This is the big one. Remember the water cushion?
The layers of water designed to absorb the launch shock.
Yes. Barbican realizes that after the shock, when those partitions ruptured, the water itself must have been ejected from the projectile.
Ah. So ejecting the water relieved the projectile of considerable weight right at the start of its journey.
Exactly. They became significantly lighter mid-flight, almost immediately after launch. That reduction in mass, combined with the possibility of a slightly higher initial speed, meant they just had enough momentum to squeak past the terrifying shortfall McNichol's equation revealed.
Saved by the numbers being slightly wrong and by their safety system basically failing in a useful way.
Pretty much. They conclude with immense relief that they are all right, saved by variables they hadn't predicted and frankly couldn't have perfectly calculated beforehand.
You'd think surviving near certain doom might bring them together, foster some camaraderie.
You would think, but no. This near catastrophe doesn't unite them at all. Instead, it immediately triggers a furious, highly technical scientific argument between Barbican and McNichol.
Over what this time?
Over the precise mathematical shape of their trajectory. Is it a hyperbola or an ellipse?
Seriously, they almost fell back to Earth, and now they're arguing geometry.
That's Barbican and McNichol for you. Barbican argues they're on a parabola eccentricity equal to unity, meaning they've achieved escape velocity. McNichol insists it's a hyperbola eccentricity less than unity, implying a looping path, maybe not a true escape.
The jargon must be flying.
Oh, it is. The text is thick with terms like directrix, focus, abscissa, conjugate variables. It's a scientific smackdown in zero gravity.
So, for us listening, the key point is their personalities, right? They're so locked into their technical disciplines that arguing abstract math takes precedence over, well, everything else.
It perfectly illustrates their obsessive natures. And again, it's Ardan who has to break it up. He bursts out laughing, calls them Stanislow scientists, basically, overly academic and pedantic, and declares that he, the only simpleton in the lot, has to lecture these geniuses on basic manners and perspective.
It really highlights the human element, the pride and rigidity that can accompany even brilliant scientific minds. That's a recurring theme for Verne, isn't it?
Absolutely. Okay, so the arguments might be temporarily shelved by Arden's humor, but the underlying scientific problem, the fact that their trajectory isn't quite right, remains. As they get closer to the moon, Barbican finally figures it out.
He identifies the cause of their deviation.
Yes. He connects the dots back to that bolide, the near miss on the first night.
Ah, the gravitational nudge we talked about.
Exactly. He realizes the mass of that enormous meteoroid, combined with the slight angle at which they passed it, exerted just enough gravitational influence to switch them off their original perfect course. It wasn't a major change, but enough.
Enough to make them miss their target landing zone.
Precisely. They realize they are now heading towards the northern hemisphere of the moon, specifically towards its northern border. They're going to miss the sender entirely.
Which means they get a very close, perhaps uncomfortably close, view of the moon's actual surface and environment. What does Barbican deduce?
He details the grim reality based on their observations and known science, the number one factor, the total lack of atmosphere.
And the consequences of that are huge.
Huge. No atmosphere means no twilight, instant transition from light to dark. More importantly, no atmospheric blanket to regulate temperature.
So extreme temperature swings.
Unimaginably extreme. Barbican calculates roasting daytime temperatures potentially reaching 500 degrees Fahrenheit, hot enough to melt tin, plunging instantly at sunset to a glacial nighttime low of perhaps 250 degrees below 0 Fahrenheit.
It's just brutal. And the sky.
The sky appears intensely black even at high noon. No air, no scattered light, just blackness and the blinding sun.
They observe specific features too, right? Like Copernicus?
Yes, they pass directly over the massive ring mountain Copernicus, which Barbican estimates is 12,000 feet high. It looks like a gigantic lighthouse from their vantage point. Arden, meanwhile, compares the cracked, rugged, desolate surface to a child's game of spillikins, or maybe a vast ancient battlefield.
And Arden, always theorizing, sees the long cracks or trenches on the surface, the rills.
And comes up with another wonderfully imaginative, totally wrong idea. He proposes these great rills are actually vast avenues of trees poplars, for instance, planted regularly on each side of a great high road.
Like lunar boulevards.
Exactly. Which Barbicane, the party-pooping scientist, immediately shoots down.
Why? What's the scientific refutation this time?
Simple astronomy. Barbicane explains the moon has virtually no axial tilt. Its axis is only inclined about 1.5 degrees relative to its orbit around the sun.
Meaning no real seasons.
Precisely. Without meaningful seasonal changes, complex vegetation like earth trees, which rely on seasons for their life cycles, simply cannot exist. No seasons, no poplars. The moonscape, Barbicane insists, is a dead, unchanging geological ruin.
Okay, so reality is setting in, and then the ultimate traumatic shift. At 6 o'clock ship time, they cross the Terminator line near the moon's north pole.
Just 30 miles from the pole itself, they calculate.
And they're suddenly plunged into what Verne calls an ocean of the most appalling darkness.
This is the beginning of the lunar night. 15 Earth days, or 354 hours of continuous, absolute darkness and deep freeze.
It's not just dark, it's instantly cold, right? And that creates a new crisis.
An immediate resource crisis. They now have to use their precious illuminating gas not just for light, which was its main purpose, but also for desperately needed heat.
Heat they hadn't really budgeted the gas for.
Exactly. Their survival margin just got significantly thinner. Barbicane reminds them just how long and how cold this night is, reinforcing how barely habitable even the moon's visible side truly is.
But even in this profound darkness, looking out over the part of the moon humans never see from Earth, they spot something unexpected.
The nickel spots it first. A flickering reddish gleam on the distant horizon of the unseen side.
What do they think it is?
They conclude it must be an active volcano. This is a huge moment, scientifically, within the narrative.
Why is it so significant?
Because it suggests that heat, geological activity, hasn't entirely disappeared from the moon. Maybe it's not completely dead beneath the surface. For Ardan especially, this single point of light is enough to reignite hope that the moon might hold some secrets, might not be entirely a lifeless cinder.
A fascinating glimpse. But despite that momentary excitement, Barbicane has to face the technical reality of their situation. They were supposed to land, they clearly haven't.
Right. After observing their path relative to the moon, Barbicane performs the calculations. The conclusion is inescapable. They have failed to land. They are now describing a predictable, stable, elliptical orbit around the moon.
Making them,
in his chillingly matter-of-fact words, her satellite forever, trapped in orbit around the moon for eternity.
How does Ardan react to that? Despair.
Surprisingly, no. Ardan actually finds the idea of being a permanent lunar satellite preferable to the alternative they briefly feared being flung off into the depths of space on an open hyperbolic curve. Being captured, even eternally, feels like a perverse form of success to him. At least they reached the moon, in a way.
Interesting perspective. But Barbicane isn't ready to give up just yet, is he? There's one last, desperate plan.
One final gamble. They calculate the point on their return ellipse, where they'll again cross the neutral point between Earth and moon gravity. This will happen at precisely 1 a.m. on December 12th.
And the plan?
Barbicane hopes to fire the powerful rockets attached to the projectile's base exactly at that neutral point.
What's the goal? To push them towards the moon.
Yes. The rockets are designed for braking. The idea is to provide just enough counterthrust at that critical moment to kill their remaining outward velocity and allow the moon's gravity to finally capture them fully, forcing a direct fall onto the lunar surface. It's their last shot at actually landing, albeit probably crashing.
High risk, high reward.
Yeah.
So, 1 a.m. arrives. Ardan is the one to fire the rockets. What happens?
They hear a dull, dead, distant report. They feel a slight fleeting shock inside the projectile, a momentary push. But they almost instantly realize it wasn't enough. The projectile, even at the neutral point, simply retained too much momentum, too much velocity away from the moon.
So the rockets were just too weak.
As Barbicane bleakly concludes, they were merely a feeble resistance against the projectile's inertia. The attempt failed. They are now irrevocably falling back towards Earth.
Following the exact same path they took outwards, just in reverse.
Exactly, a perfect gravitational reversal. And the speed of that fall is calculated to be just as terrifying as the launch.
How fast?
They're set to hit Earth's atmosphere at about 7 miles per second. That's the same velocity they had leaving the Columbiad, roughly 25,000 miles per hour. an impact that would surely vaporize them.
The narrative tension is incredible. And then Verne pulls this amazing shift in perspective, right? Away from the projectile.
Totally. Suddenly we're not in space anymore. We're on the deck of a U.S. warship, the Susquehanna, out in the Pacific Ocean off the coast of California. And they're doing something completely mundane.
Taking deep-sea soundings, measuring the ocean depth.
Exactly. 21,762 feet deep, Verne tells us. Miles deep. And then, out of the night sky.
Streaking down, incandescent from atmospheric friction. The projectile.
It screams down, impacts the ship's bowsprit, the spars sticking out the front, shearing it clean on, and plunges into the deep sea. Verne even gives coordinates. Latitude 27 degrees, 7 minutes north, longitude 41 degrees, 37 minutes west, specific as always.
So they survived atmospheric re-entry, somehow, but now they're at the bottom of the Pacific.
That's the assumption. The news flashes around the world via telegraph. And the reaction back in Baltimore is pure chaos.
Tell me about the public reaction. It's kind of funny, isn't it?
It's hilarious and very telling about human nature. A near riot breaks out. The city completely divides into two factions.
Who are they?
You have the Belfasters, named after a rival inventor who stubbornly clung to the scientific calculation that the projectile must have become a permanent satellite. They refused to believe it could come back.
And the other side?
The loyal Barbicanites, who insisted the crew would somehow return against the odds. The arguments get so heated that the police end up making mass arrests of the city's most respectable citizens.
That's brilliant satire. The Belfasters even try to discredit the ship captain who saw the impact.
They do. They denounce Captain Bloomsbury of the Susquehanna as unreliable, suggesting he just saw a storm squall or maybe a regular meteor, an aerolite. They refuse to accept evidence that contradicts their firmly held scientific beliefs.
Verne's definitely making a point there about how belief and, well, maybe political stubbornness can override even direct observation.
Absolutely. Anyway, Barbican's loyal friend, J.T. Maston, and the Gun Club Committee, they don't hesitate. They charter ships and rush to the reported impact site.
And the recovery effort involves something quite advanced for the time.
Yes. They deploy the Nautilus, not Captain Nemo's, presumably, but a specialized deep-sea submarine boat to search the seabed.
But they face a huge problem.
A massive problem. The projectile is lying in water over 4 miles deep. The hydrostatic pressure at that depth is immense, far greater than the Nautilus is designed to withstand. It can't get anywhere near the bottom.
So it seems hopeless. They survive the fall, but they're trapped, unreachable, destined to be crushed or suffocate at the bottom of the ocean.
It looks that way. Days pass. The search continues, almost out of duty, and then Captain Bloomsbury, the same captain who saw the impact, spots something.
What is it?
A shiny metallic object, just barely breaking the surface, bobbing slightly in the waves.
It's floating. The projectile is floating. How is that possible? It's made of aluminum, weighs thousands of pounds.
Another unexpected variable. Another fortunate failure saves them. Remember the water cushion again?
The water that was supposed to absorb the launch shock, but got ejected.
Verne assumes that water completely escaped the projectile at some point, maybe during re-entry or impact. So the empty aluminum shell, now weighing only around 10,000 pounds without the water ballast, was actually buoyant enough just barely to float, mostly submerged but visible at the surface.
Saved again by something not going according to plan. The water system failing twice, once to save them from the math, once to save them from the ocean depths. That's incredible.
It's a spectacular, almost comical climax of fortune and accidents. So the recovery boat carefully approaches this bobbing metal sphere. The tension is immense. Is anyone alive inside?
And then they see it.
They see the small trapdoor on top open slightly and a pole emerge with the American flag attached. They're alive.
And then they hear a voice.
Yes. A dry, incredibly calm, drawling voice shouts out from inside the projectile. Queen! How is that for hi?
Queen? What?
It's McNichol. Unbelievably, he was apparently playing cards poker, presumably inside the floating projectile to pass the time and keep calm.
That is peak McNichol, playing poker after falling from the moon into the Pacific.
You couldn't make it up. Then our Don follows with a cheerful shout in French, confirming they are all alive and well. Proving, perhaps, that the meticulous planning of the Baltimore Gun Club was ultimately just slightly less reliable than sheer, unpredictable, chaotic chance.
What an ending to the journey itself. But Verne takes it one step further, doesn't he? Into the legacy.
He does. Their return is, naturally, a massive national triumph, and it leads directly to the formation of a new, ambitious organization, the Grand Interstellar Communication Stock Company, the GICS.
GICS, that sounds very proto-NASA or maybe proto-SpaceX.
Exactly. Verne is absolutely looking towards the future here, towards the commercialization and expansion of space exploration.
What's the stated goal of the GICS?
It's huge. Championed by its new president, Barbicane, its goal is twofold. First, to establish direct communication with the moon, and second, eventually, to facilitate actual locomotion, meaning physical travel, between the members of the solar system.
So it transitions the whole adventure from a one-off scientific stunt into this ongoing visionary commercial enterprise.
Precisely. And the book leaves us with Barbicane utterly defined by his unwavering commitment to this massive project, though he does briefly suspend his GICS work, Verne notes, to dedicate his genius to helping organize the upcoming centennial celebration, the 100th anniversary of the American Republic. A nice patriotic touch to end on.
So wrapping this all up, Verne gave us this incredibly detailed, deep dive into early orbital mechanics, the physics of space travel as he understood it. But what's the core takeaway for you?
For me, it's that tension. The constant battle between precise, rigid scientific calculation and the messy, chaotic, unforeseen reality. Barbicane and McNichol represent the peak of 19th century rationalism, but their plans are constantly upended.
By things they couldn't predict.
Exactly. What's amazing is how much Verne did anticipate or extrapolate correctly. The immense velocities needed, the harsh realities of the lunar surface, the vacuum, the temperature extremes, even the bizarre physiological effects of weightlessness and, surprisingly, oxygen toxicity.
But the ultimate lesson seems to be humility. That even the most rigorous science couldn't account for random space debris, or simple human error like Ardan leaving a tap open, or the unforeseen consequences of a safety feature like the water cushion being ejected.
Right. The journey technically was a failure. They didn't land, but narratively it reshaped the world's perspective within the story. It kind of confirmed the moon was likely lifeless, yeah. But it simultaneously ignited this massive commercial and scientific ambition to still reach it, to conquer it, embodied by that GICS.
It fueled the dream, even while revealing the dangers. Maybe we should leave our listeners with that quote from Ardan during the journey. It really captures their unique situation.
Oh, that's a great one. Let me find it. Here. We inhabit a new world, peopled by ourselves alone, the projectile. Ardan is Barbicane's fellow being, and Barbicane Nichols. Beyond us, outside us, humanity ends, and we are now the only inhabitants of this microcosm. It just perfectly encapsulates the isolation, the stakes, and that defiant courage.
Which brings us to our final thought for you, the listener. Think about this. The best science of the day, within the story, predicted either absolute failure or eternal orbit for the projectile. Yet it came back, thanks to a tiny, uncalculated gravitational nudge from a passing bolide and an accidental reduction in weight from the lost water, saved by errors and unforeseen events.
So if even this meticulously planned scientific journey was ultimately saved by its failures and deviations, maybe consider this. What great professional goal, or maybe even personal project in your own life feels like a failure right now? Could there be an unknown variable, an unexpected bit of buoyancy from jettisoned baggage, or a necessary deviation you haven't accounted for that might still make a surprising return, or even ultimate success, possible down the line?
Yeah. And think about Barbicane's sheer, single-minded, unstoppable nature. A force that, as Verne shows us, even the cold, hard math of science couldn't fully predict, contain, or ultimately defeat. Something to ponder.